Okay, it's time to get going on this thing again. I've been kind of busy with work and travel and stuff like that. So, I think we have everything now to start putting this together more seriously. And still need to work on the clock circuit. I need to be able to halt and start, single step. Be nice to be able to have a single step for the microcode and then a single step that counts to 16. So you do instructions. So I'm not quite sure how to accomplish that yet, but we'll get to that point. What I have noticed though is I'm sort of running out of room on my backplane. I have some pretty big boards now. I have the instruction microcode machine, and now we have some ROM-RAM boards, stuff like that. So I thought what I'd do is, let me grab one. I thought I would add a second backplane, and what we'll do is, let's see, is that in the frame? Yeah. So we'll have two of them, and we can start parsing things. So we know ROM and RAM is actually not part of the CPU. One could make an argument that the address decoder is part of the CPU, but certainly not the RAM and the ROM. But if it's a multiplex design, we could say this is not part of the CPU. The ALU, which is this, is part of the CPU. Program counter is part of the CPU. I/O is not, so we should remove the I/O and put it over here. And a bus monitor would not be part of the CPU. We do have the greater than, equals, or less than, or 0. We do have that board, so we can add that to our ALU section. So it just goes vertically. So we have a lot here vertically. Like I said, program counter. Okay, so what else do we have? We have the state machine. So the state machine needs to go onto the CPU. And let's see, what else do we have? This is 0. These are extras. This is an extra program counter. ROM RAM. Yeah. Okay. And then we have these hex displays. I think what we'll do is do a hex display on the as an I/O device. And then I think also we would like to see data. So we have an input register. I think we should have an output register too. So I think we'll take one of these registers and we'll put a hex display on that too. So we can have maybe this doesn't go here. Let's see. So something like this. We'll have data input. We'll have data output. We'll have a bus monitor, just for debugging. And so this can all go on our peripheral devices, and this will be our CPU devices. So what I thought I'd do is maybe take these two, maybe a new one. Take two of these backplanes, mount them together, maybe on a piece of wood, just to attach them, so it's all one unit, and then start wiring this up hardwired instead of all of these jumper wires here. I think we know what's going on now. So yeah, I think we'll do that. And then once we have the CPU section and the I/O section and the program section, we can start looking at like I said, developing the clock circuit so we can single step and things like that. And then we should be able to load a program and have it go through there. I think the first step for learning how to program this thing, though, is we single step some, or at least step them slowly. We step some microcode, and we always had the instruction set to 0, 0. And so we need to write some different instructions, and so when we change the address lines, we go to a different location inside the ROM, and we execute different programs. So I think the easy way to do that would be just to have a program counter, have the program counter load 0 into here and try that microcode out, then have the program counter increment by 1. So now we have address 1 as the instruction. Then we have instruction 2, and instruction 3, instruction 4, and we can just see if we can have different instructions and see if we can operate that way. And then after that, the next thing I wanted to try was a jump instruction. We haven't tried that yet. So the jump instruction would take some value and load it into the program counter. And if we can load 0, 0 into the program counter, then we can loop easily. We could go from 0 to some number and then loop back to 0 and have it repeat. So I think that's where we need to go next. So anyway, I think the next project will be trying to make this a little neater, put it on a board so it doesn't flop around, and then start to hardwire this thing so we can be more serious about writing code for it. Alright. I also wanted to mention these boards. This is a Kim Uno board, a bare board, and this is the Zeta, the Z80 Zeta board. There's been a lot of interest in this Zeta board, and people are wondering when I'm going to get around to putting parts on this thing. I have ordered some parts. I do intend to do this someday, probably in October, something like that. But I do want to put that together. I did, like I said, I couldn't find any of these boards, so I built my own, and I had extras, so I put those on eBay, and they very quickly sold out. So I've ordered a second run of these boards, so if you're still interested in boards like this, I've ordered 20 more boards. Those should be coming in the next few days, and I'll put those 20 boards back up on eBay, so people have a chance to buy this board if they want to play with that. There's already some videos online of people building these boards and stuff, so you don't need to wait for me. You can go see what other people have done. And there's the great website of the guy who actually designed this thing, Sergey Kislev. Just go to his website. It tells you everything about it, all the source codes there. This is where I got the PC boards, where to buy the parts, everything. So very nice little project. The other project is the Kim Uno. Originally I had I couldn't find any boards, so I built my own and sold the remaining ones. And there was a lot of interest in this board as well, so I ordered 10 more boards, and those are back up on eBay. So if you want to do the Kim Uno thing, run off to eBay, and you should be able to search for Kim Uno and find the boards online. Alright, just thought I'd give you an update.